Can everybody hear me on the wireless mic? No? Ooh, okay. How about now? Is this better? Okay, hold on. Here we go. There we go. Is that better? All right, so there's a little technical difficulties there. Okay, so you guys may or may not have noticed, I'm not Allison. Allison's away at a conference right now, and I'm Austin. You're one of the two head TAs for 154, and I'll be teaching lecture today and on Friday. And lucky for me, we're going to be learning about multi-table joins for the next few days, so that's going to be a lot of fun. I got lots of help from watching past screencasts and stuff, so it should be at least okay. One thing that we should do before we get started is there's a few administrative things, or just one. So tomorrow we got a exploration session coming up. So if you haven't been to any of these before, on Thursdays, we just go over some extra topics about web programming and just really briefly explain like the gist of it. And tomorrow we got RTA John, it's right up here in front. He's going to be talking about Node.js, which is a really popular framework which you could use JavaScript basically to do a lot of things you could do with PHP that we've been doing so far with PHP. So if you want to learn about that, 4:30 tomorrow in Mu 153, that's going on. Anyway, so now we could start talking about some SQL stuff. Something we need to go over really quick is we had a little extra stuff to go over in Allison's code from last lecture. So one thing that we had going on is we didn't talk about exceptions for errors with PHP. So there's kind of a lot of things that could go wrong with a query. So for instance, if you do your query wrong just by saying your select statement wrong or something, you'll encounter errors with your SQL query itself, but in your PHP error, it won't show up as a descriptive error of what went wrong. Like what will happen is I'll show you with our past lecture example code. So we had this countries with the highest populations, nice little web page here. So what it did was it went in and it just grabbed these countries. If you look at the code here on my tiny little Sublime text open, hold on. What it did was it made a new PDO object, used our username and password there, and then it got the rows from this query here. So it just went through and said it wanted the name of all the countries, limit it to 10, and you wanted them in the order of the descending population, so that way you'll get the top 10 countries. And then it just goes through, loops through all of your results in a for each loop and puts it in these list tags. So that's what you're seeing output here. So that's pretty simple, but then we could see what happens when we mess up our statement here, our query. So you could see that this is an invalid query because it changed its highlighting and all that, which is one first check you could always do. But let's see what happens when we upload this and see what error we get. So if we upload this, we get this error here. So if you look closely at it, it doesn't tell us anything about what we did wrong with our query. It just tells us that our for each loop over the results wasn't good. So that's not really what we're all about here. We kind of want some sort of nice explanation of what went wrong. So what we'll do is talk about this slide here. So there's really just one line of code you could add to make this a lot easier, and it's this method you could call on the DB object, around the PDO object that we called DB. So really you just have to call the setAttribute method, tell it this weird long string, or two long strings here, that basically just tell it what error mode you want it to go into when there's an error. So if you're like me, you'll just say, okay, I'll just copy and paste it from the slides and put it right here. So this is something that will save us a lot of trouble with debugging and things like that, because really you could save that, upload it, and let's see what happens. Okay, so now we got a different error here. It still looks pretty ugly, and it's a PHP error, but it tells us we got a uncaught PDO exception, and it tells us that we have an error in our SQL syntax. And I think, let's see. Yeah, so it just tells us what our request was again, so it's just helpful for debugging, and it's a more descriptive error. And in the past, we've always been really big on anything that makes your coding life easier. So on your homework, the next homework that's coming up for SQL queries, definitely include this error checking line of code. So I'm telling you that now, so kind of rewarding you for coming to lecture. Oh yeah. Yeah, so this one's not one that you want to take out when you submit it, because it's a little different than debugging code. Like we're big about taking out debugging code when you take things out, but this is actually something that's like it's like a more helpful error, because like you'll get an error back either way if you have an error in your code. So we want it to be like a descriptive error. That's a good question though, so that's a good thing to keep in mind. So with that, that's kind of like the baseline for what you want to do with your homework. What it does also, which you don't necessarily have to pay too much attention to, is that you could actually catch these errors. So if you're familiar with like a try-catch block, you could do like try to do this whole thing, and then you could, let's see here, catch, and I think it's PDO. And then if you catch that error, you could say like print out some error message. So you could just say something went wrong. And then hopefully I got all that right. But what this does is it allows for easy like error checking if you wanted to do that also. So let's see. Oh, unless you make an error with your actual PHP syntax. So let's see here. Lecture files, PHP online, 32. Okay. So 32. I closed this here. Oh, right. Yeah, so I want this to be a variable. Yeah, thank you. Yeah, I'm going to need some help from you, probably the TA area, during this lecture. So let's see if, oh wait, yeah, I actually need to upload it too. Okay. So now when we get that error, it just, shows us an error message that we made. You don't necessarily need to be doing that on your homework. That's just, a nice thing to know. Is there any questions about the, that past lecture or the exception? All right. So now we could move on to bigger and better things here. So now we need to do like more complicated SQL queries than we've been doing so far. So let's see what we got here so far. So in our last lecture, we're doing things with countries with the highest population, right? So a little review of just some syntax here. If I was doing select star, if you select everything from countries, you get all these rows, and it's just really wide. So what was our like syntax for like reducing the wideness of this output? Like what do we need to do if we don't want all of these columns? Yeah, yeah. So the select star is just giving us all the columns, right? And we really just want like, things we might care about, like the name. Maybe I just want like the name, region, and population. So I could just say name, region. And now we're getting back this, nicer result here. Um, so that's good for, reducing the wideness of that. So what about the tallness? Like, how did we get rid of like having, too many row results? Yeah. Where is it? Yeah. So use limit. So if we, like in our example that we just had a second ago, we have limit, and if we wanted like 10, you can say limit 10. And just remember that limit always goes at the end. It kind of causes problems if it's there before. Yeah, so, and also we could do like order by population like we did in our example in that last PHP thing that we just did. And it's giving us population in increasing order, which was the opposite of what we did in the exercise, but essentially, same concept. One thing that's interesting to keep in mind that's kind of subtle and you may not think about is just like the fact that not having this population row in my output like doesn't affect my ability to order by or do any operations with it. So you could see that like the same output is produced, but we didn't like even select that row or do anything with it. So that's kind of something to keep in mind. And then in addition to this, like we're learning how to limit our results here in the table, right? But if you think about it, like I could just like select star and then put this in my PHP and then just choose the rows that I want or like the columns that I want. So why are we learning like how to filter down in the SQL query? Like what's some like reasoning that would be behind why we're filtering it now? Yeah.
Because some databases are really big and you don't want to hold as much data as possible
Mm-hmm.
because a lot of data is possible.
Yeah, yeah. So that's a really good point because this database could be like huge. Like we could, put a lot more information about the countries because there's lots of information to have there. And if we just pull it all out, like that's a lot of data to have. And like you need to remember that you're putting this result table into your PHP, and it's kind of going into this array type object, array type PDO object, and that's kind of a lot of wasted space. So if you just take in this huge array into your PHP and then just decide you want a little bit of information from it, that's kind of, it's against the kind of principles that we've been teaching throughout the intro classes. Like we want to keep our data as small as possible to do whatever we need to do. Another good thing that you kind of learn about databases is that the actual queries itself are really fast. So they're really efficient queries and stuff, just the way that the database is structured. So if you do all of your filtering here first, it's going to be really quick, and then in your PHP, the more slow operations, you could limit the amount of slow operations you do in PHP. So that's kind of the little spiel about making your queries really good. So on the next homework, you'll have to look out for being really efficient with your queries. Is there any questions about that? Okay, cool. All right, so now that we did a little review there, let's see, I don't need this anymore. So we learned how to do exceptions for errors, but then now we're going to talk about related tables and keys. So we've been staying pretty much within the realm of querying one table. So unless you got a little ahead in section yesterday, you may not have seen things that involve tables interacting. So there's kind of a few important things to know about every table if you want to make them interact. So you want to know about the primary key and the foreign key of every table. So the way to think about this is like how you like relate individual rows. So this row is like identified by this primary key for Bart. So if you haven't seen the Simpsons database before, it just has the student table, the teachers, courses, and the grades. And you kind of have to work with these different tables to get different queries. The primary key of like the students table, for instance, would be the student ID. Because that's like a unique ID that identifies every row. So that's how you'd think of the primary key. The foreign key would be anything that you are using to relate to another table. So for instance, courses has the course ID that tells you what course it is. So that's its primary key. But then it also has this teacher ID that tells you which teacher teaches that course. The teacher ID doesn't describe the course itself. It just describes a relationship to the teacher table. So it's like how you know where to go in the teachers table if you're looking for information. Hold on one sec. So if we're thinking about this, these kind of relationships here, let's just consider like, hold on. Let's consider like this row of the table here. So it's over there on the right. I'm just highlighting. So like the first row in the grades table, if you were to translate that into something meaningful in English, like what would that be? Like what information you're being presented with right here. Yeah? Yeah. How about getting like even more specific, like something that somebody like, would help them understand more? Or I could ask on somebody. Yeah. Yeah. So it is describing like that. This person with this student ID took this course ID and got that grade. But if you were to translate it into English, you want to say something like, yeah, Bart took computer science 142 and got a B minus. So that's something where it gets into these operations that are easy for you to do visually, but you have to translate it into kind of computer syntax to get it to go. Because the computer, like if you're querying this table, it doesn't automatically know that this student ID goes to Bart and this course ID goes to computer science 142. You need to go through and actually tell it to relate those things. So that's what we're going to learn how to do now. And you do it through using these primary and foreign keys. All right, real quick here. So why do you think databases are structured this way? Like, why do you think we do this thing where we're splitting up these tables into separate tables and using keys to relate them? Like, wouldn't it be easier just to put it onto one big table? Yeah. Mm. Yeah, and that's actually a really good example there because if one student's taking more than one course, like it gets into this weird like thing where do we have multiple columns where it's like course 1, course 2, course 3, or do you just have to reorganize your entire database? So you run into problems with that. Another problem is that if you have multiple students taking the same teacher, for instance, would be another one. So you'd have this, the students going down these rows. So you have every student, and then in the teachers column, you just have these teacher names being repeated a lot of times for all the students that have taken more than one teacher. And that just gets into having redundant data. So redundancy has always been a big issue, a big thing that we try to tackle in these intro classes. So we're going to also remove that. So we also remove that in databases. So really what this allows us to do is we have one entry for every teacher. We just relate them to other students, and it makes it so updating the database could be an easier task. That's a little more into the theory of databases than you need to know. It's just good to know before. It's good to know like why we do it before moving forward. And that's what we call normalizing, which you could click on this link and learn a little more about it if you want. Oh yeah, that's a little further than I want to go. So let's go back to our query tester and actually talk to the Simpsons database. Okay. So yeah, so let's say that we just want to figure out like which grades Bart got. So we have some like tables down here. Oh, I should probably here. Let's see. Trying to get rid of. Does anybody know how to just clear this box here? Or this, just refresh, oh. Ah, yeah, good call. So easier than I thought. So yeah, we have our Simpsons database down here. So if we want to see which grades are for Bart, we're actually going to have to get into this idea of joining the students table with the grades. Before we move into that, let's just talk about like what a join is. So if we want to select star from grades, so if you just do that part, you see all the grades that are entered in that table. But let's see what happens when we like join students. All right, so we get this much larger table here. So one thing that happens here is that we're kind of joining these two tables together, and we end up with 54 total rows. Originally, we had 9 rows returned. So what's like that relationship going on there, like between those table sizes? Yeah.
It seems to be creating a new row with roughly possible combination of rows from one table to another.
Yeah. So what it's doing really is it's combining all of the rows in the table in both tables we selected here in students and grades in like every possible combination. So really what you're getting here is a table that's of length, it's students length times the grades length. So it's like a little more than we want. If you look at what's going on here, we have all of the times that Bart got a B minus being combined with all the names of all the students. So, and then it's just going through and saying like all the times Bart got a C, combine it with all the students, and so on. So it's combining our tables, which is part of what we wanted to do, but it's giving us this like gibberish that we don't really, we can't really do anything with this because it doesn't make sense to join like Bart's grades with Lewis's grades or with Lewis's name. So this is where we get into the on clause of a join. So if we want to say on, join students on, then you put like some condition. So what's the condition that we want to be true when we're matching these up? Yeah. Yeah, so what we want is we want the student ID to equal ID. Like we want the student ID in the grades table to match the regular ID in the students table. So we'll say on student ID equals ID. And what we should get here is we have all of this information of actually linking Bart's name and email address to his grades, and actually matching all the other students with their grades too. So you could see how we could tailor this easily to a more specific query. We could say like where let's see, where name equals Bart, and then just submit that, and we get like just Bart's grades and his name and stuff. So you can see that what we got there is we are now able to search the grades table by using Bart's name. Beforehand, we only had access to this ID, but now we could actually say specifically, just search for a name. Because a lot of people, when they're starting out with SQL queries, they might just say where, student ID equals 123, and try to search that way. But what this does is it actually, you have to memorize all the student IDs, or you actually have to do another query to get the student IDs. But really what you want to be able to do is just say, where name, actually putting in somebody's name. And this is helpful for if you want the user to input data into an input box and say what name are you searching for, you can just take directly out of their input box the name and put it into your search query. So that's kind of where these joins come in. Does anybody have any questions about the join so far? Yeah. Sorry, what was that?
In that table, you seem to still have redundant data in the form of the same ID twice.
Yeah. So this is redundant data that the way that we'd get rid of this redundant data is just by filtering our select statement. So we'll just tell it to only select the name and the grade. So you can say name and grade. And then that's kind of how we get rid of that. Because really what happens is, if we look back at the select star, these relationships are built off of matching columns of rows. So we actually need to have matching data in 2 rows to enable it to link up. Yeah. Yeah, it's you. Yeah, so you should just be able to put this condition in any order, just as long as you're specifying some relationship between the tables. Yeah, so that's actually a really good segue into our next topic here. I'm always surprised how well these questions segue into the next topic. So we could actually give names to tables. So you can imagine that there are 2 tables that might have the same name for a column. If, for instance, let's see, courses. Courses just has ID for its, one of its columns, and then students just has ID as the name for one of its columns. So what we could actually do is do some naming here. One way to do it is to just say you could say on grades.studentID equals students.id. You could actually specifically say the table name and just specify that I want to look in the grades table and look for the student ID, and the students table and look at the ID column. But there are other ways to do this. There's a more common way that people like to do is using naming the tables, a shorter name. Because if you start doing this, if your query is really large, if you'll have to keep typing grades over and over again, keep typing students over and over again. So really what you could do is give your tables aliases, which I'll talk about right now. So students.id. So what we could do is we could say anytime that we first say the table name, we could put a letter after it. So we could say from grades G. And now this G is an alias for that table. And then we could say join students S on student ID equals ID. And then where this helps us filter out tables with the same column names is we could say G.studentID equals S.ID. And this is like the one place in the class where we'll say use of one letter names is fine, because it's common practice in SQL queries to use really short names to refer to tables, because you're going to have to do a lot of table referencing in your code or in your query. Something that throws people off about this a little too is that if I wanted to, again, just select the name and the grade, like up here I could say select or s dot name and g dot, what was it, grade? And the query still runs. You might think that like, oh, I declared this alias down here, like how does it know to do it up here? But really, like, alias naming isn't really like variable naming, and SQL queries aren't really a read top to bottom kind of code. It's more like it reads in the entire query and then just processes what that query means. So you could put like this declaration of what the G alias is below when you actually use it, and it will work out fine. So that's just something to keep in mind. I always like to use the table naming because it just makes me really sure which tables I'm always talking about. Is there any questions about that so far? Okay. So now let's move on to like making this a little more complicated here. So what is this? Right, so what if we wanted to, do both the courses? We want to find what courses have been taken by both Bart and Lisa. So this, I already talked about this a little bit, but this is like a suboptimal query that solves this problem. What they actually did here is put hard code the student ID in and hard code Lisa's student ID in to try and find out which class they took. So, just like the problems I talked about before, it requires us actually knowing their student IDs, which is not what we want to do. Let's see what's next. Right, so let's actually work on building the query. So if we want to know what courses are taken by both Bart and Lisa, let's take out this and look at the data for a second. So we have so far like this kind of structure to work with. So it's tempting to think like, I just want like my where clause to say like I want the where clause to ask for both Bart and Lisa's name. Say something like where name or where s.name equals, put in Bart's name, and then say like or s.name and what we'll see that comes back from that is what we're really getting is like we're just getting any row of the table that either has Lisa's name or has Bart's name included, and that's not what we want. So some people, you might think like, oh, okay, I can just switch this to and, which is like the intuitive way, like the way we've been programming before, you'd think that would maybe solve our problems, and then we get nothing. So if we look at this without the where clause again, when it's looking for those conditionals, it's actually looking for like a row where name both equals Bart and also equals Lisa, which you can't really do because there's one row for name and that's it, so you can't do that comparison. So what do we like need in order to compare that? Like how can we, oh yeah. Yeah, so we need another join. So really what we want to do is join again so that we have another name column that shows like the same kind of thing. So it shows people that have taken these certain classes. And then we want to say where this name column and this name column equals Bart, for instance, and the other names column equals Lisa. So we need to actually like expand the width of our table here with a few more joins. And this gets a little more like complicated than the one we have set up so far. So let's think here for a second. So what we have is we're going to have one like course, and we're going to have one grade for. So like this is something I should touch on a bit here. So when you're trying to link students to the courses, like there's no direct link. So students doesn't have a course ID in it or anything to reference the courses table. But if you look at the grades table, we have both student ID and course ID. So we could actually like use the grades table as our path to the courses table, like join to the grades table and then join to the courses table. So like use that to leap over there. So what we have in this process is we have like one specific set of grades for BART and one grade. And then we're also going to have one student so what's happening here is there's going to be one course overall that they're both taking. Both students have their own like set of grades, and then both students have their own place in the student table. So if you think of it like in that path, like that kind of path, like then you know how many joins you need to do. Like the way to think of it is since there's only one course that's shared between the two of them, you should select from courses. And then you have to kind of join the grades for BART, and then join the student table for BART, join the grades for Lisa, and join the student table for Lisa. So that's kind of your path towards that goal there. So what's important here is like we want to start with the courses. And I'll just select star from the start so we can see all the tables here. So if we select star from courses, I'm going to go ahead and give these some aliases so I could easily reference them later. So from courses, join. So we're going to do like 2 joins of grades here. And so it might be helpful to name one G1. And then we want to grade it where c.course ID, or c.id, sorry, equals g1.course ID. And, oh, yep. Yeah, so remember to put your from clause in there, thanks. Yeah, so we're selecting from courses C, joining the grades G1 on this condition here. And first, like, let's just set up this one where it's like join students. And this will be like, this will be the student table for BART first, so you could call this one BART on ID. Okay, so like this first step is just saying I want one path from courses where I go through the grades table in order to join to BART's, like a place where I could grab BART's student ID. We'll actually make it grab BART's student ID in the where clause, so that'll come later. So I guess we could write like the where clause first. We could say where BART dot name equals. So that would be the first part of our where clause. But we still need like those extra rows in order to get Lisa there too. So like I talked about before, we want to join again a second grades table and just say on G2 dot course ID. And we'll do a similar thing here, just say join another student's table. And I'll call this one Lisa because it's referring to a place where we'll search for Lisa's name. And just say on Lisa dot ID equals oh, right, yeah. Then put the on there. So let's just look at it without the where clauses first, just to see what we're getting back here. And I should probably remove this. So if we submit the query, we're getting, well, a lot of data back. Let's kind of look at this real quick. Okay. So maybe we should, filter out which columns we want. Or let's see. Yeah, so let's just select like the student name. Let's do G1 or select in this order. Okay, so let's actually just select only columns that we might care about here. So when we're doing this, you could see that we're getting all the combinations of students who took these classes. So what we're doing is we want to make sure that the class they took, they took the same class. So if we look over here, we have a list of all the classes, or a column of all the classes. So what we're looking for is one of these rows that both has Bart's name and Lisa's name, which you could see happens right here. So what we really did was we made all the combinations of students who took the same class. You could see that it even matched Lisa with Lisa in that row, because Lisa took the same class as herself. But we're pretty close with this query here. Really all we have to do is say where one of the students' names, is Bart, and the other student's name, and I forgot. And the other student's name equals Lisa. And the only class that they took together was Computer Science 143. So that's kind of the process here. This is the first introduction to it. We're going to talk about it more on Friday. So if you're a little confused about it now, it's okay. Just do some of the practice on the section slides that we didn't do yesterday. But this is as complicated as we're going to get with these joins. So what this problem we're solving here is we're looking for two entities in the table that had another entity in common. So we're looking for two students that had a course in common, and that's kind of a search query that comes up a lot. It's one of the more complicated search queries that would actually come up often. So that's the reason why we're teaching it. So really what you need to know is that for however many things in common, or for however many students you want to find something in common, or people, if you're doing the IMDb, how many actors had something in common, you just want to do that many join paths. So if there was a clear path from one table to another, it would just be one join for each. But since there is this table that we had to go through in the middle, there's two joins for each student. So that's what we're going on about here. So let's see if we have some more stuff. All right, so I'm going to take a little time at the end here just to talk about the next homework then. So the next homework is going to be posted, should be soon. I have this version right here. But what we're doing is we're going to use the IMDb database that we kind of tailored for this assignment to do the 1 degree of Kevin Bacon. So this one's a pretty fun assignment. What you do is like, there's this idea that if you look for any actor in any movie, like you could link them back to Kevin Bacon, like through like 6 degrees of separation. So like you could say, this person's been in a movie with this person, and that person was in a movie with Kevin Bacon, and that's like how they're linked. The site that we're gonna make is just, it will show like any like actor that's been in a movie with Kevin Bacon. So like if an actor has been in a movie with Kevin Bacon, you'll find that in your results. What we're going to do is, it has one for just searching all the movies that an actor has taken, and one for the actual searching for movies with Kevin Bacon. And we'll use like SQL queries like we've seen today. So I think like reviewing the join type queries that we've been doing in class and in section would be really good for this one. And part of this assignment has to do with actually putting that data into HTML tables, and I'll talk about that on Friday. Is there any questions about that, about the homework? What was that? This is the last assignment, right? Yeah, so this will be the last assignment. It'll be due next Wednesday, and then you'll just have the next week to study for the final. So that's how that will go. Yeah, so that's all I had planned for today. Feel free to ask me any questions, and see you guys on Friday. Thank you. Oh, yeah.